Hello and welcome to the Toshogu Podcast, where we break down the latest news, breakthroughs, and ideas shaping the future of artificial intelligence. Today, we are exploring a mysterious AI model that appeared out of nowhere, totally took Silicon Valley by storm, and the shocking revelation of who actually built it. Let's begin.
I have been so eager to get into this one. It is just a wild story.
Okay, let's unpack this, because the sheer magnitude of this stealth drop genuinely challenges, how we even think about product launches.
Oh, absolutely. It breaks all the standard rules.
Right. So it is mid-August, and suddenly, on platforms like OpenRouter and OpenCode, this model just materializes.
Out of thin air.
Literally out of thin air. It's called Ox Alpha. And there was no company logo attached to it.
None.
There was no PR campaign. There was no polished blog post from a CEO explaining the vision. It is just a blank slate API endpoint.
Yeah, just sitting there waiting to be used.
But the specifications attached to it were absolutely insane. Like right out of the gate, it boasted an over 1 million token context window.
Which is huge.
Huge.
Yeah.
And it was fully multimodal, meaning it was natively ingesting text, images, and video. And it was heavily specialized for complex coding and, sustained agentic workflows.
And we should probably highlight the craziest part of that whole equation.
Oh, the price.
The price. It was completely free to use with 0 stated rate limits.
Which is just unheard of for a frontier model.
It really is. And the numbers surrounding that initial launch phase are truly staggering, especially when you consider the sheer compute required to sustain them.
Right. Because compute is not cheap.
Exactly. When Ox Alpha appeared, the anonymous provider claimed they had the back-end infrastructure capacity to serve up to 100 trillion tokens per day.
100 trillion. Wow.
Yeah. Now, they didn't actually hit that ceiling during the preview, but the reality of what they did process was just as mind-bending.
What were the actual numbers?
So in a mere 6 days, this unknown, completely unbranded model processed approximately 44 trillion tokens.
44 trillion tokens in less than a week. That's almost hard to visualize.
Right. And it handled more than 13.1 million completed sessions from roughly 500,000 unique users.
So it basically took over the developer community overnight.
Pretty much. With those kinds of metrics, it instantly became the #1 most used model of the week across those platforms.
It's like a 3 Michelin star chef suddenly parking a nameless, rusted food truck on the corner of a busy street.
That's a great way to put it.
And just handing out free, world-class tasting menus to anyone who happens to walk by. People are going to take notice, right?
Oh, yeah. They flock to it.
We even saw Patrick Collison, the CEO of Stripe, publicly testing it on complex tasks and calling it very impressive.
Which is a huge endorsement.
Right. When someone at that level validates an anonymous tool, the hype just becomes an absolute inferno. So what stands out to you about how developers reacted so quickly?
Well, I think the speed of adoption really came down to the elimination of a very specific, very painful technical friction.
Okay, what kind of friction?
So developers weren't just casually playing with it. They were throwing massive workloads at it because it solved this context compression issue that usually plagues long-horizon agentic work.
Let's break that down. What does that look like in practice?
Okay, imagine a developer trying to rewrite a legacy Python application, right? And it has 50,000 lines of code spread across 50 different files.
A pretty standard but messy enterprise project.
Exactly. Normally, when you feed a model that much text and ask an AI agent to run autonomously to debug it, the system starts to hallucinate.
Because it just can't hold it all in its head.
Right. It forgets variables declared in the first file by the time it reaches the 20th file. The context compresses, the logic breaks down, and the agent just fails.
It loses the plot.
It totally loses the plot. But Ox Alpha demonstrated this incredible resistance to that degradation.
Oh, wow. So you could just feed it everything.
Yeah. Developers could dump an entire repository into a single prompt and get coherent cross-file debugging.
Which is the holy grail for a lot of these engineering teams.
It is. The community recognized immediately that this wasn't some, consumer toy. It was enterprise-grade infrastructure just masquerading as a free preview.
Which set off literally the most frantic guessing game I have ever seen in the tech community.
Oh, the theories were wild.
Everybody was trying to play detective. The prevailing theory for days was that this had to be Microsoft, right? Secretly beta testing a new frontier model from their MAI family.
Yeah, that was the big rumor.
Because the sheer compute required to handle 44 trillion tokens in a week led almost everyone to assume it had to be backed by a Western mega-cap tech company operating in stealth mode.
And what's fascinating here is the absolute paradox of the clues the community was actually working with.
Right, because there were clues pointing in a completely different direction.
Exactly. You had Chinese users who very quickly noticed this cultural through line, and they gave the model a nickname, New Lie.
You lie. Which means what, exactly?
It translates roughly to, here comes the ox.
Ah, okay. Hence, Ox Alpha.
Right. It was a clear nod to internet memes and the bull demon king from classical Chinese mythology.
So a very strong cultural fingerprint pointing directly to a Chinese origin.
Yes. However, at the exact same time, Western users were stress testing the model with politically sensitive prompts.
As they always do with a new model.
Of course. Specifically regarding Chinese domestic policies and history, and Ox Alpha was answering them openly.
Oh, I see.
Yeah, it completely lacked the strict, recognizable guardrails that are typically mandated in that region.
Which is a huge contradiction. And I have to say, that lack of censorship became the ultimate camouflage.
We really did.
It completely threw investigators off the scent. Because Western developers looked at the cultural naming convention, then they looked at the uncensored outputs, and they decided their geopolitical assumptions held more weight than the cultural evidence.
Right, they assumed the guardrails would be hard-coded.
Exactly. The logic was essentially, if it speaks freely about sensitive topics, it categorically cannot be a Chinese model. But is that actually a safe assumption to make?
Well, no. It is a perfect illustration of heuristic blind spots. We rely so heavily on pattern matching.
Right.
The assumption is that foundation models are immutable reflections of their geographic origin. But behavior in a neural network can be adjusted or fine-tuned or even deliberately left unconstrained for a specific data gathering phase.
Because at the end of the day, a model's guardrails are just an applied layer, right? Not the foundation itself.
Exactly. The engineering team behind Ox Alpha clearly understood that removing those guardrails would effectively render the model stateless in the eyes of the global community.
They knew exactly what they were doing.
Oh, 100%.
So the tension finally snapped a few days later, late August. The mystery was solved, and it was a massive mic drop.
A total shock to the system.
Ox Alpha was officially revealed to be a GLM 5.3 Flash.
Yeah.
And the creator claiming it was Z.ai.
Z.ai, right.
The laboratory, formerly known as Z.ai, which originally spun out of research from Tsinghua University in Beijing.
And that revelation forced an immediate recalibration across the entire industry.
Because suddenly all those assumptions about compute dominance were challenged.
Exactly. Z.ai finally released the technical architecture of GLM 5.3 Flash. And it is a mixture of experts model, commonly referred to as MOE.
Okay, MOE.
And they trained it on a multimodal corpus of approximately 30 trillion tokens.
30 trillion.
Yeah. In total, it boasts 320 billion parameters.
Okay, let's pause here, because the mixture of experts architecture is honestly brilliant.
It's a very clever way to handle scale.
Let me try an analogy here to explain MOE. Think of it like a massive global corporation. You have this company with 320 billion highly specialized employees.
Okay, tracking.
Those employees are your total parameters. But if a client calls in with a highly specific question about, say, optimizing a front-end web database, the CEO doesn't put all 320 billion employees on a single conference call.
Right. That would be chaotic.
Yeah.
And insanely expensive.
Exactly. The hourly billing would bankrupt the client. Instead, the system routes the query and only pages the 18 billion specific specialists who are actually qualified to answer that exact question.
That is a really great analogy.
It keeps the computational overhead remarkably low while still maintaining access to this massive, diverse pool of knowledge.
It captures the routing mechanism perfectly, but GLM 5.3 Flash pushes that efficiency even further.
How so?
By utilizing what Z.ai categorizes as a hybrid attention architecture.
Hybrid attention, okay.
Yeah, this combines sparse attention, linear attention, and a mechanism known as manifold constrained hyperconnections, or MHC.
Manifold constrained hyperconnection.
I know, it's a mouthful.
The terminology in this field never fails to sound like a sci-fi drive core.
It really does sound like something out of Star Trek, but the mechanism itself is incredibly elegant.
Break it down for us.
So in traditional models, attention mechanisms are often brute force. They treat every single word or token in a prompt with equal computational weight.
Like reading every word with the exact same level of focus.
Exactly. It is like a lawyer reading a 500-page contract word by word and paying just as much attention to the standard boilerplate as they do to the actual liability clauses.
Which takes forever and burns a lot of energy.
Right. And that is why processing a million tokens gets exponentially expensive. Hybrid attention, specifically utilizing MHC, changes that.
Oh, so it skips the boilerplate.
Basically, the model dynamically learns to allocate processing power only to the most critical semantic nodes within that massive context window.
That's fascinating.
Yeah, it scans the document, maps the manifold of the data, and essentially ignores the boilerplate, drastically reducing the energy required to process enormous projects.
So what does this all mean for the end user? Because now that the commercial version is officially listed, Z.ai is claiming a 1.3 million token context window.
Which is just an astronomical amount of data.
We are talking about dropping entire libraries of reference books, days of audio transcripts, and massive enterprise code bases into a single prompt.
Yep, all at once.
But hold on, a 1.3 million token window is phenomenal for marketing. But we have seen models boast massive windows before, only to fail miserably when you actually test them.
Right, the real-world application doesn't always match the spec sheet.
You drop a huge codebase in, and it completely hallucinates the middle of the document. Is GLM actually retrieving this information, or is it just swallowing it without crashing?
That is the vital distinction that gets lost in marketing materials. There is a massive gulf between nominal context capacity and perfect information retrieval.
Okay, unpack that.
So a 1 million plus token window simply means the system architecture will accept and process that payload without throwing an out-of-memory error.
It won't crash.
Right.
Right.
It does not guarantee that the model will weight every piece of that information perfectly when formulating its output.
Yeah.
Users will still experience degradation in recall.
Especially for the stuff in the middle, right?
Exactly, particularly for data buried deep in the middle of a massive context payload. It's the classic needle in a haystack problem. It is a profound engineering achievement to process it cheaply, but users must understand that a massive context window is not equivalent to a flawless photographic memory.
It is the difference between building a library large enough to hold 1 million books and hiring a librarian who can actually find a single sentence on page 400 of a book you dropped off last Tuesday.
That's exactly right.
Now, as fascinating as the MHC architecture is, the geopolitical reality of this reveal is the real earthquake here.
Oh, without a doubt.
Z.ai is sitting right on the United States entity list, meaning their access to advanced American technology, specifically high-end AI accelerators and semiconductors, is heavily restricted.
Right. And if we connect this to the bigger picture, the operational reality of this launch is profound.
How do they pull it off?
Well, Z.ai stated publicly that the massive 44 trillion token preview, that entire stress test that captivated Silicon Valley, was served entirely using a large-scale cluster of domestically developed Chinese AI chips.
Entirely domestic chips. Wow.
Yeah. They utilized a high-bandwidth interconnect and proprietary inference optimizations to achieve that throughput without relying on top-tier Western silicon.
Let's pause on that interconnect detail because it is crucial.
It really is the secret sauce.
Right. If you can't buy one massive, hyper-advanced chip to do the heavy lifting, you are forced to string together thousands of slightly less capable chips. But to make them act like one unified supercomputer, the data has to travel between them at light speed. That high-bandwidth interconnect is the glue making this domestic cluster viable.
Exactly. It's about networking them efficiently.
And that raises a massive question. Does this suggest that Western export restrictions haven't actually stopped Chinese AI development, but rather forcefully accelerated the creation of a massive, fully independent domestic tech stack?
The deployment metrics certainly validate that hypothesis.
It seems like it backfired in a way.
Well, the strategic goal of restricting hardware access was to maintain a generational bottleneck in computational capabilities. However, GLM 5.3 Flash demonstrates that scale and efficiency can be achieved through alternative hardware architectures.
Right. If you can't go through the wall, you build a different kind of ladder.
Exactly. If a laboratory can serve a frontier-level model to 500,000 users simultaneously, processing trillions of tokens, relying entirely on a domestic hardware stack, It fundamentally alters the global technology landscape.
It really does.
It signals that the capability to operate at the absolute frontier of artificial intelligence is no longer geographically centralized.
And on top of that distributed capability, Z.ai dropped the other shoe, which is the pricing model.
The pricing is, well, it's aggressive.
The promotional pricing is aggressive, but even the expected standard pricing for GLM 5.3 Flash is clearly designed to break the market.
Oh, yeah.
We're looking at 15 cents per million input tokens and 50 cents per million output tokens.
To contextualize that for the enterprise sector, that pricing structure completely upends the current market equilibrium.
It changes the math on everything.
It really does. It forces every engineering team to reevaluate the fundamental cost basis of their AI integrations.
Let's look at the actual benchmarks for a second. Z.ai published extensive results showing GLM 5.3 Flash going toe-to-toe with absolute heavyweights like Claude Opus 4.8 and GPT 5.6 Tera.
The heavy hitters.
Right. Now, it doesn't sweep the board. It wins in specific automation and complex tool use tests, but it loses slightly in other areas, like certain multi-step coding evaluations or the agent's last exam.
Right, it's a mixed bag at the very top end.
But my argument is that winning a benchmark by 2 points simply doesn't matter anymore if you have an incredibly capable model that is 10 to 50 times cheaper for agentic workflows.
That is the turning point.
If I have an autonomous AI agent running 24 hours a day analyzing millions of tokens of server logs, I do not need it to be a tiny fraction of a percent smarter on a standardized test.
No, you don't.
I need it to not bankrupt my engineering department.
You are describing the exact strategic pivot the industry is currently undergoing.
Yeah.
For the past several years, the sector has been intensely fixated on achieving the absolute highest benchmark score, chasing the crown of the theoretically smartest model.
The vanity metrics.
Right. But GLM 5.3 Flash introduces the commoditization paradigm. The model does not need to be the undisputed best in the world across every metric.
It just needs to be good enough.
Good enough, remarkably cheap, and seamlessly integrated. When frontier intelligence transitions from being a premium, scarce resource to an abundant, low-cost utility, the application layer changes entirely.
Because you aren't rationing it anymore.
Exactly. Developers stop optimizing the cost of a single prompt and begin automating entire departments.
Here's where it gets really interesting, though, and frankly, quite terrifying for the developers who were eagerly testing this thing out all week.
Yes. The fine print.
There is a serious privacy trap hidden in the fine print. During that massive 6-day free preview, OpenRouter had a warning in their listing that a staggering number of people completely ignored.
I mean, developers see free and they just click start.
Exactly. The provider, which we now know was Z.ai, retained both the user prompts and the model completions.
So the security implications of that oversight cannot be overstated.
It's a nightmare.
It is. You had hundreds of thousands of developers seduced by the promise of free, unlimited access to a powerful model, eagerly uploading their proprietary environments.
They were feeding this anonymous, endpoint-sensitive company data,
Unreleased intellectual property.
and potentially even internal database credentials hidden deep within legacy code.
Yep. They handed this data over to a completely mysterious entity without thoroughly auditing the data retention policies governing that specific proxy endpoint.
It is a massive reality check.
A very expensive lesson in operational security.
Now, the provider did state the data wouldn't be explicitly used for future training, but the fact remains that it was retained on their servers.
Right. It's sitting there.
It highlights how instantly we abandon basic security protocols when someone dangles a shiny, capable, free tool in front of us.
We are very easily distracted by the shiny new toy.
We are. And speaking of reality checks, we need to clarify the actual openness of this model.
This is an important distinction.
Z.ai is offering the weights for download under an MIT license, which is great for researchers, but it is strictly an open weight model, not a fully open source model.
Exactly.
The training data set, the internal filtering decisions, the exact training pipeline, all the ingredients used to bake the cake remain entirely closed and hidden.
Precision in terminology is essential here. Open weight accurately describes what developers receive, which is the compiled, finalized neural network capable of being deployed on proprietary infrastructure.
But they lack the foundational recipes.
Right. Furthermore, the nomenclature Flash might be slightly misleading for the casual developer. Well, in this context, Flash refers to the inference efficiency and the subsequent pricing model, not hardware accessibility. Even with an incredibly efficient mixture of experts routing system, deploying this requires the entire 320 billion parameter architecture to reside in memory.
Meaning you are absolutely not running this locally on a standard consumer laptop.
No.
Not even close.
You need multi-GPU servers, serious enterprise compute clusters, or specialized cloud environments just to load the model. It is an enterprise-grade beast, not a lightweight local app.
Exactly. The efficiency of the Flash architecture is about how cheaply a massive server farm can serve answers at scale, not about fitting a frontier model onto a consumer hard drive.
When you step back and look at those 6 days in August, the true genius of the Aux Alpha phenomenon wasn't just the technical achievement of the mixture of experts routing or the domestic hardware cluster.
No, it's bigger than that.
It was the fact that this wasn't a standard product launch at all. It was a perfectly executed psychological experiment.
A blind taste test for AI. Exactly. By completely stripping away their brand, their nationality, and any geopolitical context, Z.ai forced Western developers to evaluate the intelligence purely on its own merits.
Which is brilliant.
There's no prejudice, there were no preconceived assumptions about censorship, and no immediate debates about trade restrictions. Developers simply looked at the code the model produced and admitted it was world-class.
And the strategy was undeniably effective. By conducting the rollout in a vacuum, they proved a fundamental thesis about the future trajectory of this technology.
Which is what?
This event demonstrates that the next phase of the global AI race is no longer merely about possessing the smartest model in an isolated laboratory. The race is now about who can deliver highly capable intelligence at massive scale, operating reliably on independent domestic infrastructure, and offering it at a price point that fundamentally disrupts the market floor.
And the blind validation they received from the global developer community is impossible to argue with.
They proved their point beyond a shadow of a doubt.
They successfully got the entire world to praise the product before revealing the label on the box. But that success leaves me with one final, deeply unsettling thought.
Uh-oh. What's that?
If a stealth drop was the only viable way to bypass geopolitical bias and get truly honest, unbiased feedback from the developer community, how long until every major tech company realizes this?
Oh, wow. Right.
How long until we see a flood of anonymous proxy models used deliberately to manipulate public perception, completely breaking our trust in how AI benchmarks, crowdsourced leaderboards, and user preferences are traditionally measured? If the only way to get a fair test is to lie about who you are, the entire concept of a transparent AI leaderboard might already be dead.
That is a very sobering thought.
That's all for today's episode of the Toshogu Podcast. If you enjoyed it, like this episode, subscribe, and join us next time for the latest in AI. Until then, keep building what outlives you.